Hey, everybody. How are y'all?
I'm good. How are you?
Good. How are you?
Pretty good. I was sorry about that. It was taking me a minute to get set up today and get everything loaded. I can start wherever you guys want me to. But I did get emails about 8, 10, 11, 14, 15, 17, 18. So I can definitely cover those for sure. And I don't know if you heard me. Maybe I'll type those so that y'all can actually see them. These will be the ones that I'm for sure covering. 8, 10, 11, 14, 15, 17, 18. If you have others that you want covered besides that, please let me know.
Can you start on 11 and go to 18 just from there, please?
Yeah. So don't start at 8.
Yes, ma'am.
Start at 10?
Yeah. Yes, I can actually start at 10. Is that okay with you, Eli? Because I know you're on a time crunch today.
Yes, ma'am.
Okay, thank you. All right, so number 10. Remember in class, a lot of you laughed at me, but it's true. Y'all trip when this happens. This is y to the 15th power. If I'm writing it as a fraction, which for a lot of you, this really, really helps so that you know what to multiply where. So you would rewrite it as y to the 15th over 1. Because when you have any number, once you put it over 1, it's now written as a fraction, but has not changed the value at all. So this is the exact same thing rewritten, but y to the 15th is rewritten as a fraction. So now we have y to the 15th over y to the 9th, which really then you use the quotient property, 15 minus 9. So that gives me y to the 6th as my answer. Okay? That makes sense to you, Mary Faith?
Yes, ma'am. Thank you.
Cool, no problem. Okay, number 11. Very similar, except this time the whole number is in the front. So we'll have z, oh, nice z, Miss Sparks, z to the 16th over 1 times 1 over z to the 7th. So we multiply z to the 16th times 1. So you get z to the 16th, and then you multiply 1 times z to the 7th. So that's now going to be my denominator. So I use the quotient property, and I subtract 16 minus 7. So that gives me z to the 9th. Okay. Does that make sense to everybody?
Yes, ma'am.
Yes, ma'am.
Okay, cool. Any questions so far?
On number 12, would you just put a to the 8th over b to the 8th?
Well, vice versa? Yes. Poor Mary Faith, you and I are two peas in a pod. I say things like that all the time. A to the 8th over b to the 8th. Yes, that is it exactly. A to the 8th over b to the 8th. You just distribute that 8, that exponent 8, to everything inside the parentheses. And that is very, very similar to what we had for the product property for exponents. Okay, so for number 13, we do the exact same thing. We're going to distribute that 3 to everything inside the parentheses. So that negative there has to either go to the top or the bottom. It cannot go to both. but it has to go to one or the other. So it wouldn't really matter which one you used it for. Your end result is going to be negative. How do I know that it's going to be negative?
Because it's an odd number.
Yes, good job. That's it exactly. So it wouldn't make any difference which one we put it to. So if you're going to put it to the 6, you know, and actually if you just kind of want to think about it, okay, it's just to the whole fraction. You can also do that. So like, since I know that that's odd, you know, I could do this. I could just put it out with the whole fraction. You can also do that. There's really a number of ways that you can do this. You can just distribute that fraction to the negative to the front of the fraction if you want to. Or you could distribute it to the top, just the top, or just the bottom, as long as you end with a negative number. And just like Mary Faith just said, we know that the end result is going to be negative because the exponent is odd. When the exponent is odd and you begin with a negative number, your end result is going to be negative. And when your exponent is even and you begin with a negative number, your end result is going to be even. So 6 raised to the third power is 216, and z to the third power is just rewritten that way, z to the third. So my final answer is negative 216 over z to the third. All right, number 14. That 4 on the outside of the parentheses is going to be distributed to everything inside the parentheses. And I do mean everything. So taking the numerator, taking it one step at a time, we will rewrite it first as a, and then we're going to multiply that 3 and 4. Okay, so that's going to be a to the 12th. Over, now distribute that 4 to everything in the denominator, and I mean everything. So that's 2 to the 4th, b to the 20th. This 5 right here, that fifth power, is only on the b. It is not on the 2. It's only on the b. There is an understood 1 on the 2. So I'm distributing this 4 by multiplying 4 times 1, which is 4. So now I have 2 to the 4th and b to the 20th. So my end result, or my final answer, is a to the 12th over 16b to the 20th. Number 15, I'm going to distribute this 5 to everything, and I do mean everything, inside the parentheses. So my numerator will now look like this, 3 to the 5th, because there's an understood 1 right there. And 5 times 1 is 5. And x to the 20th, because 4 times 5 is 20. And that's the product property of exponents that we learned about on Monday. And now that 5 being distributed to the y in the denominator, 6 times 5 is 30. So I have y to the 30th. So my final answer is going to be 243 x to the 20th all over y to the 30th. If you left it like this, I would not be disappointed on a test or anything like that. Just good exercise to put some of those smaller numbers like 2 and 3 in the calculator raised to some of the higher powers, just so you get accustomed to what they look like. Big numbers like 12 and 8 and stuff like that, please don't take those to real high numbers. But what would be most important on a quiz or a test to me is that you know to distribute this 5 to everything. And I reiterate, everything inside the parentheses. Because what seems to happen, and I reluctantly show this to you, let's rewrite this problem up here. I reluctantly, but I just want to show you what happens. On a test, you guys have a tendency to do this. You don't distribute it to anything like just randomly, okay, let's just pick the X. And not everything gets touched. The 3 never gets touched. Sometimes the Y does, sometimes it doesn't. But it's very interesting to me. That 5 gets distributed to everything. Everything inside the parentheses.
So if you were to simplify it completely, would you do 3 to the 5th power and then just simplify that?
That's the only thing that you can simplify on that particular one, because you can't, this is an X to the 20th and that's a Y to the 30th. And those two cannot be combined. They have to be like terms to be combined.
Okay.
Great question though. Okay. Number 16. Well, my goodness. So that 3 gets distributed to what? Anybody know the answer? What's the magic word that begins with E? Oh, come on.
Exponent?
Play along with me. Huh?
Exponent?
Yeah, the 3 gets distributed to what inside the parentheses? Everything. Everything inside the parentheses. The 3 gets distributed to everything inside the parentheses. So starting with the numerator, m to the 12th, because 4 times 3 is 12, right? And then we'll have 5. Do I distribute the 3 to the 5?
Yes.
Yes, good job. So 5 to the 3rd power. And then n, I'm going to multiply that 9 and that 3. So that's going to be n to the 27th power. And so then that my final answer would be m to the 12th over, nice m, 125 n to the 27th. And that's as far as you can go because you cannot combine the m and the n. All right, number 17.
Is that
The
125 n to the 7th?
You got n to the 7th?
Like, I can't read that.
27th. M to the 12th. That's a 12.
Okay, that makes more sense. Thank you. I couldn't see the 2.
Oh, yeah, I know. Sorry, it's written right on that instruction. It's kind of hard to read. Sorry about that. That 4 gets distributed to everything inside the parentheses. So starting with the numerator, 3 to the 4th, and now I'm going to multiply that 7 and that 4. That's x to the 28th. And then that 4 gets distributed to everything in the denominator. That's going to be 2 to the 4th. And then 4 times 12 is 48. So my final answer is going to be 81, because 3 to the 4th is 81. x to the 28th all over 16y to the 48th. The x and the y are not like variables, so they cannot be combined. So that is my final answer.
Can you keep it there for just 1 second?
Absolutely. I'm just only going to race over here so that I can start on 18. Let's try to leave it there for you guys for a minute. Okay, number 18. That 5 gets distributed to everything inside the parentheses. So that 5 gets distributed to starting with the numerator. That's going to be 2 to the 5th. And now I'm going to multiply the exponent 5 with the other exponent right here. 5 times 5, because that's what you do to a power to a power. So that's going to be m to the 25th all over, distribute that 5, 3 to the 5th, and then 9 times 5 is 45. So my final answer for number 18, 2 to the 5th, is 32. M to the 25th, can't simplify that any, and 3 to the 5th is 243 n to the 45th.
We're not supposed to do 19 through 21, correct?
Oh, no, baby, you're not. Good question, though. I would definitely tell you that, like, things, a lot of reasons that I include these is a lot of parents ask me, what are some good ways for my student to be able to work on ACT, SAT skills. And so on these practice A's and practice B's that I give you guys, believe it or not, those are great, great things to use to practice ACT, SAT skills.
That's good to know.
So, yes. And so that's a lot of times why I include those. And if you also want additional practice at the end of every unit in my book, there is a what they call a standardized version of the chapter test. Those are also very good for the ACT, SAT prep. So if you guys ever want those, I'm kind of glad that you asked about this question. If you guys ever want those, please let me know and I will email them with the answer key, just so that you guys have ways to practice, because I know those are all expectations that you all have. So, I'm happy to share those with you.
Hey, could you do numbers 7 and 9?
7 and 9. Absolutely. Oh, are you guys still there?
Yeah, we can hear you, but we can't see your screen.
I'm so sorry, guys. I don't know what happened. Okay. I'll get it figured out. Hold on. Can you see anything now? You can just hear me, right?
We can only see your little icon, but we can't see the screen.
Okay.
Just share your screen with us again.
I will, but when I tried to make it a little bigger to show to show you guys the sheet, obviously I did something. Um,
Yeah. Do you want some rice too? Do you want rice? I want to.
sorry, now it's taking the computer a long time to bring up my documents, but I'm coming. This is like watching water boil. I'm like, okay, come on, come on, come on. Technology, you know, a curse and a blessing. Can y'all hear my dog snoring? Okay. Grayson, you asked about number 7, correct?
Yeah, I
Hopefully
did. And
won't do
someone
that
else
again.
did too.
Okay. All right. Number 7. Number 1, what you want to look at is we've got a negative inside the parentheses. So is my exponent even or odd?
For number 7, it's even.
Okay. So with a negative number, I know my final result is going to be positive because an even exponent with a negative number, I know that my end result is going to be positive. If it were odd, it would be negative. But I'm going to distribute that 6 just like I have everywhere else to everything inside the parentheses. So I would have 1 to the 6th over 5 to the 6th. Okay? And 1 to the 6th is what? What is 1 to the 6th power?
It's 6. I was trying to write and unmute my microphone at the same time.
No. 1 to the 6th power is 1. 1
Yeah.
times 1 times 1 times 1 times 1 times 1 equals 1. That's how that goes. Does that everybody understand that? That's a pretty common mistake, Grayson. So my final answer.
I thought that because 1 times 6 is 6.
Yep, I know. It's a very common mistake. So you're going to have, like I say, you can do one of two things. You can distribute that negative to everything inside the parentheses and write your answer like this. Or you can write your answer like this. Actually, it's not going to be negative, so it won't really matter. If you left your answer like this, I would really be okay with that. Just knowing that you have to distribute everything inside is what's most important to me. And knowing that my preference would be this, actually, because I would love to know that you guys know that 1 to the 6th is 1. I would also love to know that with an even exponent, there is no negative anymore. This would be what would show me that you really understand exponents. But as long as you're distributing, I'm good with that. Does that make sense? That one has like lots of ways that you can write it. So I can see why you would want to see that one done. So 1 over 5 to the 6th. Everybody understand that?
Yes, ma'am.
Okay, cool. All right, number 8. Is that the other one you wanted done?
No, it was 9.
9. Okay. 9. So that's going to be 1 to the 5th because I've got to distribute that 5 to everything inside the parentheses. So beginning with the numerator. Now this 4 to the 13th, I'm going to rewrite it as a fraction, right? Beautiful, beautiful fraction. Looks like a question mark. I'm going to rewrite it as a fraction because that's a whole number. And you guys, it's just so much easier for you guys to visualize when you rewrite that fraction. Take the time to rewrite that fraction because when it's written like this, for whatever reason, you all get very confused by that. So please take the time and go, okay, Miss Sparks says, don't let this trip me out. Just rewrite it as a fraction, put it over 1, so everything at the top lines up and everything at the bottom lines up. We've already learned that 1 to any type of power, whether it's 5, 6, 20, 100, is still going to be 1. 1 to whatever power is 1. And then 4 to the 5th times 4 to the 13th over 1. So then the next step, I'm going to multiply 1 times 4 to the 13th and 4 to the 5th times 1. And now I just use my quotient property, and my final answer is 4 to the 8th. Same thing on number 8. If I put this over 1, I'm going to have 3 to the 8th over 3 to the 1st, which equals 3 to the 7th. Don't let the fact that you're multiplying an integer, like a whole, written as a whole number times a fraction, just go ahead and put that whole number over 1. Do that every time so that you don't get messed up.
Okay, I have a quick question.
Okay.
Are you gonna be going over the guided practices today?
Oh, for 7.3? I can do that. I didn't even think about it, but I would be happy to. Grayson, I'm so glad you brought it up.
Yeah, my sister was asking to let her know if you're gonna do it.
Oh,
So
okay.
Courtney should be joining in a few minutes.
Okay. I forgot all about it, but I am so happy to do that for you guys. Let's go there.
Thank you, Miss Sparks.
These are fun. Yes.
Thank you.
Somebody said Mrs. Sparks.
Yeah, I
Yes?
have to go. Thank you for your help.
Oh, you're most welcome, sweetheart. I hope you have a great day.
You too.
Bye-bye. Okay. All right. Let's see. Make sure I can write. Okay. So the guided practice for today, the main principles of what you were learning today, the easy one is when any number raised to the 0 power is always 1. Doesn't matter what it is, it's always 1. Whether it's a fraction or a negative number or whatever it is, if the outside number is a 0, it's always 1. So the answer to number 1 of the guided practice, anybody want to volunteer?
1.
Yay! Good job, Grayson. It is. That is the answer to number 1. So, what's the answer to number 4?
1.
1. Good job. It's not a trick question, I promise. I'm not trying to set you up. So the answer to number 1 and 4 is 1. Okay? Is there anything that you guys don't get about that? It seems weird, but it is. I've got a really weird, crazy video that actually proves it. So I might post it just for any nerds like me that like to learn about stuff like that.
Wait, is number 2 a fraction 1 over 64?
Good job. Indeed, it is.
Yeah.
So that negative, good job, Grayson. You're all over it. The negative number in the exponent just simply changes the position of where the number is. So that instead of it just being a regular 1 over negative 8 raised to the negative 2 power, what that means is I take the negative off of the exponent, not the 8, and I do it like that. So now I rewrite it as 1 over negative 8 squared, and then that becomes 1 over 64. On number 3, because the negative, yeah, okay, because the negative is in the denominator, it forces it, it pushes it up. So that means we're going to rewrite this. Since that negative is in the denominator, it now pushes to the numerator, and you remove the negative. So if it's in, like here, this is the same, remember, as negative 8 over 1. That negative in the exponent drives it to the denominator. On number 3, the negative in the denominator drives it to the numerator. So now it's 3 cubed over 1. So it just pushes it to where it wasn't.
Okay.
Okay? All right. Okay. Number 5. We're supposed to evaluate the expression. So you have 1
Is it 1
over
over
4 to
64?
the negative 3. So what's going to happen to that? Can you see it?
Up.
It pushes up. Good job.
So isn't
So
it 1 over
this,
64?
it's going to, if it pushes it up, it's going to go to the numerator. So that's going to be 4 to the 3rd power, which is 64. If it pushes up, see, it's going to the numerator. So that 4 to the negative 3 is now in the numerator with no negative exponent. Does that make sense? No? Yes? Those are the steps. It goes up to the numerator. Now, on number 6, what you have to do first is apply the power property. What do I do in the power property? If I have a exponent raised or a power raised to a power, what do I do? What do I do with the exponents?
You would multiply.
Multiply. Good job. You would multiply them. So what's a negative 3 times a negative 1?
3.
3. So that equals 125. All right. On number 7, we have the same bases, okay, raised to powers. And they're being multiplied. So the same base being multiplied, what do we do with the exponents?
You add. Maybe.
Same base. What do we do with the exponents?
Don't you add them?
You add them. Good job, Grayson. You are doing great today. You are on fire. So, what is 5 plus a negative 5?
0. So the answer should be 1. All right.
Good job. That's it. Perfect. I'm so proud of you.
Thanks.
All right. On number 8, we're going back to the quotient property. So take this one step at a time. Let's think about this. With the quotient property, with the same bases, what do?
You subtract. So isn't it 6 to negative 4?
6. Oh, good job, Grayson. It is 6 to the negative 4th, which then would tell me that it drives it to the denominator, right? Sorry, that looks like a 64. That's supposed to be a 6 to the negative, or 6 to the 4th power. I'm sorry, guys.
How did you get negative 4?
Negative 2 minus 2.
Okay. Negative 2 minus 2. You've got negative 2 at the top, negative 2, and the quotient property says to subtract. So that's negative 4. Because I've got a negative 2 at the top, minus 2. Minus 2 minus 2 is a negative 4. Does that make sense?
Yes, ma'am. I was making it so complicated.
Okay, cool. Okay, that's okay. We have a tendency to do that.
But
Sometimes
why-
we want simple things to be hard and hard things to be simpler.
Why
So
did you
now we
put
have
1 over 6
1
to the
over
4th?
6. 6 to the 4th. And then that actually is this, but I don't really care if you didn't do it. But if you stick it in your calculator, you would get 1 over 1,296. Was that all the guided practice, or are there more?
So I had a question on number 8. Since there's a 1 on top, you can't just like take away the 1, right?
No, because if you just took away the 1, that's 1,296 is a very different number than 1 over 1,296. 1 over 1,296 is a itty bitty teeny tiny fraction. Does that make sense?
Yeah.
Okay.
So what's the answer for number 8?
But great question. Great question, because that's a great clarification question, because I know that we all students have a tendency to do that when they're reducing things. They will leave out a 1. And when we're flipping and flopping all this stuff, they'll leave out that 1 in the numerator. It's kind of a common thing. So I really appreciate the fact that you brought that out and we had a chance to talk about it.
What's the answer for number 8? Because you have like 3 separate things.
Oh, sorry. Basically, I took it one step at a time, but the final answer, let me erase some of this. This was the final answer to some of this other stuff. The final answer is that. We go from 6 to the negative 2 power over 6 to the second equals, and then we reduce that to 6 to the negative 4. Then to get rid of the negative exponent, we did 1 over 6 to the 4th. And then we plugged in what 6 to the 4th is, and we get a final answer of 1 over 1,296.
Okay.
Thank you so much.
Oh, no problem. Thanks for coming to Math Lab. Hey, and thanks for reminding me about the guided practice problems. We did great in Math Lab today.
Yeah. But what's funny
Y'all are
is
so smart.
That was very polite, Courtney.
it's just Grace and
Good.
Courtney and you.
Oh, is it?
Yeah.
Oh, well, y'all have, you Carmichaels have a great day.
You too.
You
Bye.
too. Thank you.
Bye-bye. You're welcome.